Hello students, welcome to the ninth lecture on the topic differential equations. So I have divided lecture 9 into two parts. So in the first part I'll talk about method to find the particular solutions for the non-homogeneous differential equations. Now in the previous lecture what we have seen how to find the general solution of the homogeneous differential equation. So in this lecture we will see how to find the particular solution of a non-homogeneous and then how to find the general solution of the non-homogeneous differential equation. So in part 1 I will be discussing method of undetermined coefficients, and as these has many cases, so I'll cover up some cases in this part and the other cases in the lecture 9 part 2. So let's start. As I told, I'll cover up in this lecture method 1, that is method of undetermined coefficients. Okay, so this method is only applicable in the case when coefficients p and q in the non-homogeneous differential equation, that is you can call it as y double dash plus px y dash plus q. You can eliminate this because this method is only applicable when your p and q are constants. So this I'll call it as equation number 1 are constant. Then we can use method of undetermined coefficients. Also this method is only useful when this rx contains some special form. So I'll write this down. So in this method what we start by making a guess of the trial solution. So I'll write down the steps. So the first step is we start with guessing the trial solution yp by looking at rx. And what is our second step? Then what we do, we substitute the trial solution in our equation and then we compare both the like terms from both the side and then we find out the constants. So after that we write down the required solution. So I'll write all the steps. So what I told in step 2 is that whatever we have made a guess in the first step, then what we do, we substitute that trial solution in our equation. Okay, and then we determine the constant, whatever it is involved in the trial solution, we determine those constants. And how we determine the constant? By comparing the terms on both the sides, and then we get the trial solution, or you can say we get the particular solution, and finally we write down the general solution for the non-homogeneous differential equation. Finally the required general solution of 1 is given by this yg plus y. This yg is found in the similar way as we did earlier. This is the homogeneous differential equation general solution. Like if you make rx is equal to 0, if you make this 0 and you can solve easily what we have done in the previous lecture, then you can find out this yg. And how will you find this yp? You will find here by two methods. Firstly we are discussing about this method of undetermined coefficients, and in the next lecture I will tell you the methods of variation of parameter. So yp is determined by this method, and then if we add both we will get the general solution for the non-homogeneous differential equation 1. So I hope this is clear. So let's start with our method. So this method is, as I have told you, that we have to make a guess looking at our rx. So this method is applicable only we have some special form of rx. So let us see what are those special form of rx. So we will mainly discuss the 4 cases and the combinations of these 4 cases. So first case is case 1, if rx is of form k e to the power ax. So we are going to discuss this form and then we will discuss other forms also. Just start with this form. So if you have this form, so that means that your differential equation 1 becomes this. So in this case what you will do, you will start with making a trial solution, that is a e to the power ax. So whenever you get a differential equation where your rx of this form, you have to make the trial solution like this. This is any constant k, so you are making a trial solution as this. Now if you differentiate this, what you will get? You will get y dash is equal to a into small a e to the power ax, and if you double differentiate it, you will get a square e to the power ax. Okay, so what is our main aim? We have to determine this unknown coefficient a. If this is determined, then we will get our particular solution. This is my yp, this is yp dash, this is yp double dash. So what I am going to do is that substitute all these values in my equation. Putting all those values over here in equation, you can say in equation 2. So comparing both sides, what are you getting? You are getting a is equal to, you can see that it is equal to 1. So I will write this a square plus pa plus q is equal to 1, and this implies your a is equal to 1 by a square plus ap plus q. Okay, so this is your value of a when this term is not equal to 0. So if it is equal to 0, then there is problem. So when it is not equal to 0, your trial solution, you will get the value of this a, and just what you have to do, you have to put in your yp the value of a, and you will get the trial solution. So I'll write down that value of a in trial solution yp to get the particular solution. Okay, so this is only possible when a plus q is not equal to 0. So you have seen that in this case the particular solution, I will write ps is taken as yp is equal to a e to the power ax. Now what will happen when you have the auxiliary equations which have the value a? Okay, so now consider the homogeneous differential equation, that is if we make this 0. Okay, so consider homogeneous differential equation. So this is y double dash plus py dash plus qy equal to 0, and the auxiliary equation is m square plus pm plus q equal to 0. So now if we put a in place of this m, okay, if we put a over here, what you are getting? You are getting that this is equal to 0. Like if your value of m is equal to, if your value of m is equal to a, then it is equal to 0. So in this case you cannot determine your value a. You can clearly see that this equation is same as our this equation, this denominator. So if in this case, if our auxiliary equations have the root equal to a, then there is a problem, then a will be undefined. So in that case, what you will do, if your a is a single root, you will choose the trial solution as x into e to the power ax. So I'll write down, if a is the single root of the auxiliary equation of homogeneous differential equation y double dash plus py dash plus q equal to 0, then the trial solution, then yp is taken as a into x e to the power x, because you have seen that in that case you cannot determine a. Okay, so this is one case, and the next case is if a is the double root of the auxiliary equation of the homogeneous differential equation y double dash plus py dash plus q is equal to 0, then the trial solution is taken as yp is equal to ax square a to the power e to the power ax. Okay, so this will be your trial solution in that case. So summarizing what you have seen, that if you have a differential equation where you find your rx is this, okay, so what will be your trial solution? Your trial solution will be this, provided that this a is not a root of the auxiliary equation. Okay, this a, looking at this a is important. If it is the root of auxiliary equation, then you cannot determine this value. Okay, so if a is not the root of the auxiliary equation which is formed by making equal to 0, then the trial solution is this. Now if a is a single root, okay, if a is a single root, then your particular solution will be this. And if your a is a double root, if you have a double root, so what will be the particular solution? You have the particular solution this. So let us do few examples to make this more clear. So find the general solution of differential equation y double dash minus 2y dash plus y equal to 6e to the power x. So this I call it as equation number 1, and using the method of undetermined coefficient. Use method of undetermined coefficient. This I have written as shortcut. to find particular solution. So first of all, let us see the homogeneous differential equation which is associated with 1. Why we are finding? Because we need to find out the general solution of this differential equation. So this is yg plus yp. So yg is what? The solution of the homogeneous differential equation. So firstly I'll write down the homogeneous differential equation associated with this. So this will be equal to 0. This I call it as equation number 2, and you know how to solve it. It is a second order homogeneous differential equation with the constant coefficient. So you will find out the auxiliary equation, and the auxiliary equation is given as this, and solving it we are getting the roots as m is equal to 1 and 1. So what will be your yg? Your yg will be c1 plus c2 because it is repeating. So your yg will be c1 plus c2x into e to the power x. Now just look at this rx now, because you want to find out yp. So what we will do, we will look at this rx. So at initial stage, what you will choose yp as what? You will choose yp as a e to the power x. Just looking at this rx, this is my rx, so you have to choose the trial solution as this. Now as I have told you that if this a is the root of auxiliary equations, then you have to multiply an x. So since 1 is a double root over here, right? 1 is double root, so you have to multiply this with x square, otherwise this a cannot determine. Okay, so multiply this with x square. So now what we will do, we will consider this as a trial solution. The trial solution is this, and now what you will find out, you will find out yp dash, that is a x square e to the power x plus 2ax e to the power x. So yp double dash, again we need to find out, that is a x square e to the power x plus e to the power x 2x plus a 2x e to the power x plus 2 e to the power x. Put value of yp, yp dash and yp double dash in equation number 1. Okay, so I did many calculations, and then after putting, what I am getting, I'm simply getting this equation. Now if you compare the coefficient both the side, so I will write down comparing coefficients of e to the power x on both side, we get a is equal to 3. So what you have done, you have find out the value of a. So if you have find out the value of a, you got yp, because if you put a over here, this will be your yp, and you have also calculated yg over here. So what will be the general solution? Yg plus yp. So I'll just write down, therefore yp is equal to 3x square e to the power x, and hence the general solution of non-homogeneous differential equation is what? Yg plus yp. So your yg is c1 c2 x into e to the power x plus 3x square e to the power x. So this will be your general solution of the non-homogeneous. So you can call it as yg, like just to make a difference between the homogeneous part. So this is a general solution of the non-homogeneous differential equation 1. Non-homogeneous means your rx is not equal to 0. When it is equal to 0, you have already seen how to solve, and you can finish. Just you need to find this yg, and that is a general solution if your equation was homogeneous. Now it is non-homogeneous, rx is not equal to 0, so you have this extra part. So this you will find with the help of undetermined coefficient, and I'll discuss the next method on the coming lectures. So now let us do few more examples using this method. Example 2 is y double dash minus 4y is equal to 6 e to the power 2x. So you can see that here rx is e to the power 6 e to the power 2x. So it's for solution. Let us first find the yg, that is the corresponding homogeneous differential equation is what? Y double dash minus y 4y equal to 0. and therefore the auxiliary equation is given by m square minus 4 is equal to 0. This implies m is equal to plus minus 2. So therefore yg will be equal to c1 e to the power 2x plus c2 e to the power minus 2x, because since this is real and distinct, so you know how to take out the yg for the homogeneous differential equation. Now see, just see this rx. If you see this rx, what will be the trial solution? So you can write this as step 1 and this as step 2. So what you will do, you will find out yp looking at rx. So I have discussed that if your rx is like this, you have to choose a e to the power 2x. Now just again look at the roots of the auxiliary equation. You can see that 2 is a single root. In the previous case 1 was a double root. Now here 2 is a single root. So what you have to do, you have to multiply this with x. So now this will be your trial solution. So this I call it as equation 1, this I call it as equation 2 is a trial solution. So now what you need to do, you need to find yp dash, that is 2ax e to the power 2x, and you will find out yp double dash. So this yp double dash will be 2ax into e to the power 2x into 2 plus e to the power 2x plus 2a e to the power 2x. So now you can see that you are solving, after solving you will get this. So now put yp dash and yp double dash in 1. What we get? We get 4a e to the power 2x plus 4a x e to the power x minus 4a x into e to the power 2x is equal to 6 e to the power 2x. So this implies 4a e to the power 2x is equal to 6 e to the power 2x, and this imply your a is equal to 3 by 2, right? So therefore your yp will be equal to 3 by 2 x into e to the power 2x. So now you have found both the part, that is your yp is over here and your yg is over here. So what will be the general solutions for this? So for the this equation number 1, that is your non-homogeneous differential equation, that will be equal to yg plus yp. So let me write down non-homogeneous differential equation 1 is yg plus yp, that is equal to c1 e to the power 2x plus c2 e to the power minus 2x plus 3 by 2 x e to the power 2x. So this will be your final answer. Now we will do one another problem and then we will move on to other cases of Rx. So this is my differential equation and I need to find out the solution. That again you can see that this is non-homogeneous differential equation because here Rx is not equal to 0. So what is our first step? We will find out the corresponding homogeneous differential equation. So homogeneous differential equation for this is, so and auxiliary equations what we are getting, this is m square plus m minus 2 is equal to 0. This imply your m is coming out to be 1 and minus 2. You can easily solve this and then you can find out that your yg, since these are distinct and real, what will be your yg? Your yg will be c1 e to the power x plus c2 e to the power minus 2x. So till here it's okay. You find out the yg of the corresponding homogeneous differential equation. Now looking at this Rx, now you need to tell me if this is your Rx. Okay. Now you need to tell me, looking at this, what will be your yp. So this is step 1 and this I'll write step 2. So looking at Rx, I will guess that yp is equal to a e to the power x. For this my particular solution will be this, plus I'll write another constant as b e to the power 2x. Now I have to check whether this part is a root of the auxiliary equation or not. So now you can see that this part is a, like this is 1 and I have a root that is single root 1, and here I have what, this a is 2, but I don't have root over here. So only one x will be multiplied in this portion, right? Because this exponential to the power ax, here I can see that a is equal to 1, which is equal to my one of the roots. So I will multiply x with this part of trial solution, this, and I'll leave this because this is not a problem. Here 2 is not a root. So I'll leave the trial solution over here. So this will be our final trial solution. What I need to do is that find, so y p dash I'll find out, that is coming out to be a to x e to the power x plus b to b e to the power 2x. And what will be the value of yp double dash? This will be x e to the power x plus 2 e to the power x plus 4 e to the power 2x. So now putting the value of y, then yp, you can write yp dash and yp double dash in 1, we get, I'm just writing down quickly, this is equal to e to the power x plus e to the power 2x. Now by some calculation you will find out that you are getting like if you collect the e to the power x1 and then collect the coefficients, you will get this, and plus if you collect e to the power 2x coefficient, you will get this. Now this will be equal to e to the power x plus e to the power 2x. Now if you compare the coefficient, what are you getting? Now if you can see, this are getting cancelled out, so I am left with 3 over here, and here also this is cancelling out. So finally I am left with e to the power x into 3 of a plus e to the power 2x 4 of b, which is equal to e to the power x plus e to the power 2x. So comparing both sides, what I'll get 3a is equal to 1 and 4b equal to 1. This implies that a is equal to 1 by 3 and b is equal to 1 by 4. So therefore your particular solution will be what? Particular solution 1 by 3 e to the power x plus 1 by 4 e to the power 2x. Since you can already see that this is your yg and this was your yp, so here now you calculated the value of a and b, so now you will put the value over here and you will get the yp as this. So what will be a general solution? Therefore general solution of non-homogeneous differential equation 1 is given by yg plus y, that will be equal to, you can write down, this is your yp and this is your yg. So I will just write down for your convenience, this is c1 e to the power x plus c2 e to the power minus 2x plus 1 by 3x e to the power x plus 1 by 4 e to the power. So this will be the final answer. Now I'll give you few practice problems. So question number 1, to solve this question, and the answer for this will be a e to the power minus 2x plus b e to the power x by 3 plus 2x e to the power x by 3. So the second question for your practice is, and for this the answer will be c1 e to the power 2x plus c2 e to the power minus 5x plus 1 by 3 e to the power 4x. Okay, so I hope you can solve these two questions. So now we will move on to the next case when your Rx is the trigonometric function in the sine or cosine. So case 2, till now we have done the case where your Rx was a exponential form, right? Now we will discuss when your Rx is of the form either this is some sine function or some cosine function, or this may be the combination of both. Then what trial solution you will choose, I'll tell you. So in such cases we take our trial solution, I'll write it as yp, this is our trial solution, we take trial solution as yp is equal to a cos of bx plus b sine of bx. Okay, so whatever will be the form, like either if you find Rx as this or this or this, okay, you will take first case, like first time at a first glance you will take your trial solution as this. Now if there is another special case here also, now if your particular solution can be obtained from the auxiliary equation, or you can say that general solution, so at the first glance you will take your particular solution as this, but however if your general solutions can be generated by Rx, okay, like your if your general solution is like this, yg is equal to c1 cos of bx and c2 sine of bx. Now you can see that there is similarity between yp and yg. Okay, so what we can do is that we can generate Rx from y, or you can say that yp can be generated by yg. So in that case what we need to do, we need to take the, when, I'll just write down, when yp is similar to yg, then the trial solution is taken as, I will write yp as x a cos bx plus b sine bx. So I'll just summarize this. Okay, so what I told you till now, that if you find your Rx is either of this form or this form or this form, then you will choose your trial solution as this at the first glance. Okay, now when you will find out the yg, you need to find out yg, correct, for finding out the general solution for the non-homogeneous differential equation. Now if you find yg and it is coming like this, and you can see that there is similarity, it means that you these both are similar and yp can be generated by yg. So in that case what you have to do, you have to multiply with the trial solution with x. So this is our case 2. So let us do few example on this case by using method of undetermined coefficient. This I'll call it as equation number 1. So for the solution here, homogeneous differential equation is given by y double dash plus y equal to 0. I'll call this as equation number 2, and you can easily see that the auxiliary equation will be m square plus 1 equal to 0, and this imply m is equal to plus minus iota, and this is the complex root. So in this case what will be your yg? You know that this will be c1 cos of x plus c2 sine of x. Obviously there is no real part, so I will have e to the power 0x. Okay, so your yg will be equal to c1 cos x plus c2 sin x. Now just see, this is your step 1, and the step 2 is that by looking at this Rx, what you need to do, this is your Rx, and what you need to do is that you need to find out yp, what will be a trial solution. So at first glance what you will write the trial solution as a cos of x plus b sine of x. Now you can see that there is a similarity between your yg and your trial solution yp, right? These yp can be generated by yg. So in this case, as I told you, what you have to do, you have to multiply this with x. So now when you multiply this with x, what you will do, you will find out yp dash, then we will find out yp double dash, and then again you will substitute in equation number 1 to find these constants. This is our task, to find this constants a and b, and when we find this constant we will find out the particular solution, and if we add both of these we will find out the general solution of our given differential equation. So let us do yp dash and yp double dash. So yp dash over here is, and yp double dash will be cos of x minus ax plus 2b and plus sin x minus 2a minus bx. So this implies, if I see, minus 2a sin x, that is I have collected this 2a sin x plus 2b cos of x is equal to, so it's coming to be this. Now putting values of yp, yp dash and yp double dash in equation number 1. This I called it as equation number 1. So finally you will observe that after putting all the equations, like all the values, what are you getting? You are getting this cos of x plus 0 into sine of x. Now comparing the coefficients of cos x and sine x on both sides, we get minus 2a equal to 0 and 2b equal to 2. This implies that a is equal to 0 and b is equal to 1. So therefore my yp is equal to x into sine of x, right? So now the general solution will be of non-homogeneous differential equation 1 is what? Yg plus yp. What will be your yg? You have already find out. So this will be your final solution. I'll call it as capital YG for the non-homogeneous differential equation 1. So let us do one more example on this. So solve this differential equation by method of undetermined coefficient. Okay, so for the solution, or step 1 is homogeneous differential equation is y double dash plus 4y equal to 0. So the auxiliary equation is given by m square plus 4 equal to 0, and this imply your m is plus minus 2 iota. Okay, so your yg will be equal to what? C1 cos of 2x plus C2 sine of 2x, right? I'll call this as equation number 2. So you did the first part, that is you find your yg. Now what is your second step? You will now look at rx. Okay, so your rx is 2 cos x. So what will be your step 2? Your step 2 will be finding out your yg by looking at this rx. So what will be your yp? This will be c, or you can write down a cos of x plus b sine of x, right? Because I told you if rx is of this form, you will take the trial solution as this. Now you can see that your this cannot be, your yp cannot be generated from yg, because here we have 2 and here we have coefficient like sine of x and cos of x. So these both are not similar. Okay, so these both are not similar, and so our trial solution will be this only. If we have here as cos 2x, we will have multiplied x, but since there it is not cos 2x, it is cos x, we will leave our trial solution as this only. So we will do yp dash and yp double dash. So just let us find yp dash. This is equal to minus a sine of x plus b cos of x, and yp double dash will be minus a cos of x minus b sine of x. Now putting the value of yp dash and yp double dash in equation number 1, what we will get? We will get 3a cos of x 3b sine of x is equal to 2 cos of x. Now comparing the coefficient of cos x and sine x from both the side, we get a is equal to 2 by 3 and b is equal to 0, and therefore what will be our yp? This will be 2 by 3 cos of x, right? This will be our yp, because here we have chosen yp as this, so we are getting b as 0 and a as 2 by 3, so our yp will be this. So what will be the general solution? And hence the general solution of differential equation 1 is yg plus yp. So that is c1 cos of 2x plus c2 sine of 2x plus 2 by 3 cos of x. So this will be your general solution for the non-homogeneous differential equation 1. So I'll just take one more example and then I'll end my this lecture. So this is solve the differential equation y double dash minus y dash is equal to cos x e to the power 2x. This is my differential equation 1. So you know how to solve, and we need to solve this by method of undetermined coefficient. So here the homogeneous differential equation is given by this, and the auxiliary equation will be equal to m square minus m equal to 0. This implies that root is m is equal to 0 comma 1, and therefore your yg will be equal to c1 plus c2 e to the power x. So call this as your equation number 2. Now what is your step 2? This was your step 1 to find out yg. Now we will move on towards finding out the value of yp. So what will be our yp? We need to look at the rx. Okay, now you can see that this is a sum of two different rx. Like for this we have a trial solution, we saw a trial solution, and for this we have a trial solution. So we will just write down this as a for cos x, it will be a cos x plus b sin x. Okay, and plus for this will be c e to the power 2x. Now you can see that there is no problem because yg is not similar to yp. So what this our choice of the trial solution is, this is okay, and therefore what we will do, we will now find yp dash. Okay, so yp dash will be equal to minus a sin x plus b cos of x plus 2c e to the power 2x. And what will be our yp double dash? So it will be minus a cos x minus b sin x plus 4 of c into e to the power 2x. Now putting the values again, same thing, putting the values of yp dash and yp double dash in equation 1, we are getting equation, and then you have to compare the coefficient to find out the coefficients. Okay, so I'll just write down 2x minus sine of x plus b cos of x plus 2c e to the power 2x. This will be equal to cos of x plus e to the power 2x. Now you can see that cos of x minus a minus b plus sin x minus b plus a will be equal to cos of x. You can check the calculations, and here also we can there is one more addition e to the power 2x 4c minus 2c, right? So now if you compare the coefficient with the cos x over here, the sin x and e to the power 2x, this implies comparing the coefficient of cos x sin x and e to the power 2x on both sides, we get a plus b equal to minus 1, a minus b equal to 0, and c equal to 2, c equal to 1. This implies your a is minus half. Okay, you can calculate easily, and b is equal to also minus half, and c is equal to half. So therefore your yp, the final yp will be cos of x minus 1 by 2 sin of x plus 1 by 2 e to the power 2x. So hence the general solutions of non-homogeneous differential equation 1 is equal to yg plus yp, and yg and yp are given over here. So I can write this as equation number 3. So you can write down your yg is given in equation number 2, and your yp is given, this is your yg and this is your yp. So you can add both to get the general solution of the non-homogeneous differential equation 1. I'll just write few practice problem for this also, for this case also. So practice problem, you need to find the solution by using methods of undetermined coefficient. Yeah. Okay, so this will be your answer. Question number 2, y dash plus 25y equal to 50 cos of 5x plus 30 sine of 5x. Okay, so here your answer will be c1 cos of 5x plus c2 sine of 5x plus 5x sine of 5x minus 3x cos of 5x. Okay, so I hope after watching this lecture you are able to solve these two questions. For this lecture I'll end over here. Thank you.